Our universe is filled with mysteries. In our technological age, artificial intelligence, or AI, has emerged as a powerful tool in this quest for knowledge. One of its most fascinating applications lies in the realm of facial recognition. Imagine a world where computers can recognize faces with the same ease as humans, or perhaps even surpass our abilities. This is no longer a figment of science fiction, but a rapidly evolving reality. AI is enabling machines to see and interpret human faces, unlocking a myriad of possibilities and challenges. The implications of this technology are far-reaching, touching upon aspects of security, convenience, and even our understanding of intelligence itself. As we delve deeper into the world of AI facial recognition, we embark on a journey that promises to reshape our interactions with technology and with each other. How do machines actually learn to recognize faces? The answer lies in a subset of AI known as machine learning. In essence, machine learning algorithms are like students in a classroom, constantly learning from the data they are fed. In the context of facial recognition, these algorithms are trained on vast databases of facial images. These images are meticulously labeled with information about the individuals depicted, allowing the algorithms to identify patterns and correlations between facial features and identities. Machine learning algorithms work in a similar way, but on a much larger and more complex scale. They analyze countless images, identifying subtle variations in facial features such as the distance between the eyes, the shape of the nose, and the contours of the lips. This information is then used to create a unique facial signature for each individual. Through continuous learning and refinement, these algorithms become increasingly adept at recognizing faces, even in challenging conditions such as varying lighting, angles, and facial expressions. The heart of AI facial recognition lies in its sophisticated algorithms. These algorithms are the engines that power the technology, enabling machines to make sense of the visual information they receive. One prominent class of algorithms used in facial recognition is known as convolutional neural networks, or CNNs. Inspired by the structure of the human brain, CNNs process images through a series of layers, each designed to extract specific features. Imagine a CNN as a detective examining a suspect's photograph. The first layer might focus on basic features like edges and lines. Subsequent layers might then analyze more complex patterns like shapes and textures. Finally, the deepest layers would piece together all this information to identify unique facial characteristics. Section 4. Facial recognition from our pockets to our cities. Facial recognition technology is no longer a futuristic concept confined to science fiction movies. It has permeated our lives in ways we may not even realize, from unlocking our smartphones to enhancing security measures in public spaces. One of the most ubiquitous applications of facial recognition is in our smartphones. Many modern smartphones use facial recognition to unlock devices, providing a convenient and secure alternative to passwords or fingerprint scans. This technology has also found its way into social media platforms, where it is used to automatically tag friends and family in photos. Beyond our personal devices, facial recognition is increasingly being deployed in public spaces for security purposes. Law enforcement agencies use it to identify suspects in criminal investigations, while airports and other transportation hubs utilize it to enhance security screenings and border control measures. Section 5. The double-edged sword of facial recognition progress and its price. The rapid advancement of facial recognition technology has sparked a heated debate about its ethical implications. While the technology offers undeniable benefits in areas like security and convenience, it also raises concerns about privacy, bias, and the potential for misuse. One of the most pressing concerns is the potential for facial recognition to erode privacy. As the technology becomes more sophisticated and widespread, there is a risk that it could be used for mass surveillance, tracking individuals' movements and activities without their knowledge or consent. Another concern is the potential for bias in facial recognition algorithms. Studies have shown that some algorithms are less accurate at recognizing faces of people with darker skin tones, raising concerns about racial profiling and discrimination. As we continue to integrate facial recognition technology into our lives, it is crucial that we carefully consider these ethical implications. Striking a balance between innovation and responsible use will be essential to harnessing the benefits of this technology while mitigating its potential harms.